This is the second leg of quadrilaterals, and we consider parallelograms, rhombuses, kites, and trapeziums in this situation. Okay, right. We are still talking about lengths, areas, and volumes, and this is the part two of quadrilaterals. In the last video, I talked about quadrilaterals focusing on rectangles and squares, and we saw from there that every square is a rectangle, but not every rectangle is a square, right? Because basically, for a rectangle, the two opposite sides are equal, and all the interior angles are each interior angle is 90 degrees. That is true for uh, squares too, except that all the sides of a square are equal. So that's what distinguishes. So a square is more like a regular quadrilateral, if you like to put it that way. Just like I say that an equilateral triangle is a regular triangle because a regular polygon in the general sense is a polygon with equal sides and whose sides are equal and the angles are also equal. All right. So let's talk about a kind of overview of quadrilateral. Again, a quadrilateral is any polygon with four sides, four vertices, and the sum of its interior angles is 360 degrees, right? So we usually focus on convex quadrilaterals where all interior angles are less than 180 degrees. So let's see some main types of quadrilaterals. So we can, in a sense, we can actually have general quadrilateral. So in this case, there's no special side or angle conditions. Like any four-sided shape is a quadrilateral. So if I can just draw this, maybe I have this, and then I have this something. Well, I mean, this is already looking like something familiar. So I mean, you can just have anything like any four-sided thing and it's a quadrilateral. So you can just say that is a regular that is a general quadrilateral, right? So and what we're saying is that all these angles, when you add them together, they all add up to 360 degrees. Okay, and then we have a rectangle, which is a parallelogram with all angles 90 degrees, right? Then opposite sides are equal and parallel. We talked about that. Then diagonals are equal and bisect each other. We also talked about that in the last video. And for a square is a rectangle with all sides equal, or you can also see it as a rhombus with all angles 90 degrees. So all sides are equal, all angles are all angles are 90 degrees each and diagonals are equal, perpendicular, and bisect each other. But we've already taken care of rectangles and squares in the last video. So now the new set of quadrilaterals we'll be talking about are the following. Uh, we have parallelogram, rhombus, kite, and trapezium. Okay. So let's start with parallelogram. So from the idea of parallelogram is that both pairs of opposite sides are parallel. I mean, it's still looking like a triangle in that sense. So you can see a rectangle, right? So you can see when we talked about rectangle, it was said that a rectangle is a parallelogram because the two sides are parallel. So that's opposite sides are parallel. Then opposite sides are also equal. That is also true for a rectangle. Then opposite angles are equal. This is where this is a bit different. Well, I mean, this is also true for a rectangle, except that uh in the sense if all the angles are equal, not just opposite angles. That's one slight difference between parallelogram and rectangle. And then the diagonals bisect each other. So it means that a parallelogram is something like this. Okay, I can take advantage of these grid lines. So imagine you have this. This is 1, 2, 3, 4, 5, 6, 7. Okay, and then I can move two steps off, and I have 1, 2, 3, 4, 5, 6, 7. Okay, and then if I join this up, if I have this, and then I join this up, okay. So you see, this side is parallel to this side. This side is also parallel to this side. Another thing is that this side is equal to this side, and this side is equal to this side. Then this angle here is equal to this angle. Okay, that's the bigger angle, so I can give it two strokes. So this angle is equal to this angle. Well, this angle is equal to this angle. That's basically what a parallelogram is. And then the diagonals, the diagonals the diagonals are equal. Oh, do we have that? let me be sure of about that equality. The diagonals bisect each other. They are not necessarily equal. Yeah, very important. So they bisect each other. That means that the length here, this length is equal to this length, and this length is equal to this length. That is what it means. They just bisect each other. So that's what a parallelogram is about, right? So this is a parallelogram. Parallelogram. Okay. So we go on to the next. We have a rhombus. A rhombus is a parallelogram with all sides equal, opposite sides parallel, diagonals are perpendicular and bisect each other. So the diagonals are perpendicular. So the diagonals meet at 90 degrees and the diagonals bisect the interior angles. So that's a lot more information right here. So a rhombus is something like a square that is stretched out. So imagine you have this. Okay, let me be very sure about this. This, this, and then you have this, this. So with this now, okay, all the sides are equal. So it's looking like a square, and all the angles that may not necessarily be 90 degrees. They are not, in fact, they are not 90 degrees because um, they are not necessarily 90 degrees. So, and okay, what are the other things now? About the interior angles, opposite sides are parallel. Okay, opposite sides are parallel. Have I done that? So this is parallel to this. This is parallel to this. Maybe I should make it two strokes to distinguish. Okay, opposite sides are parallel. What else? Diagonals are perpendicular and bisect each other. So they're perpendicular and they bisect each other. Okay, so this is a diagonal and this is another diagonal. They meet at 90 degrees. Okay, and they bisect each other. So that means that this side is equal to this side and this side is equal to this side. Okay. I think there's a very important information there still. Diagonals are perpendicular and they bisect each other. Diagonals bisect the interior angles. Okay. Yeah. So that tells us that this angle, of course, this angle is equal to this angle, is equal to this angle, is equal to this angle. Not necessarily. Okay. So this angle is, and all these angles are the same. And then this and this are also the same. So that is a rhombus right there. Okay. Now, very trickily, we are going to talk about a kite. A kite is just like a rhombus, except that all the sides are not the same. Okay. So for a kite now, we have two pairs of adjacent equal sides. So for a kite, we have two pairs of adjacent equal sides, one pair of opposite angles equal, diagonals are perpendicular, one diagonal bisects the other, and bisect the angles between equal sides. So a kite is like a rhombus, but the only difference is that in the case of a kite now, well, for a rhombus, maybe you have this, you have this, and then for a kite now, the other side is now like longer than that square looking thing we had for a rhombus. So you can then have this, and then you have this. So this side is equal to this side, and this side is equal to this side, and then the opposite angles are equal. So this angle is equal to this angle, while this angle is equal to this angle. So uh this diagonal bisect the other diagonal and they meet at 90 degrees, just like the other rhombus we considered the other time. So we're saying now that, okay, like I think there's something about the diagonal that we should talk about. So diagonals are perpendicular, all right? One diagonal bisects the other and bisect the angles between equal sides. So in this case now, this diagonal bisects this other one. Uh, so I feel it is only the longer diagonal that bisects this. This and this are the same, but we can't particularly say that this side is the same thing as this side. I don't think that won't be true from what the picture even looks like on its own, right? So this is basically a kite. So you can see the difference between a rhombus and a kite now. A kite is like a rhombus, except that you have a diagonal longer than the other in a kite, but for a rhombus, the diagonals are exactly the same length like we saw before. So for a rhombus, diagonals are perpendicular and bisect each other. Diagonals bisect at right and bisect the interior angles and all that. Okay, then we can now have a trapezium. So in a trapezium, at least one pair of opposite parallel sides. So at least one pair of opposite sides parallel. The parallel sides are called bases. Then we have a special case, which is an isosceles trapezium, which is non-parallel sides are equal. Then base angles equal. Diagonals also equal, right? So, but I mean, in a general sense, a trapezium is something like this, or what you can even call a trapezoid, trapezium. Okay. For a trapezium, you have, let's say, um, okay, this side is parallel to this side, maybe something like this, and this comes, so this side is parallel to this side, right? But then there's nothing, so that's the main thing you have here. So in this case now, we can then say this is a base. You can say this is base one and this is base two. Now, this is really important because we need that information later when we begin to talk about the area of a trapezium. That's really important because here we now need to think about the height of the trapezium. That's really useful in looking for. So this is like the height now. So we need to be able to get the height for us to be able to get the area as we move on later. Okay, so those are the new quadrilaterals you're talking about: parallelogram, rhombus, kite, and trapezium. And thankfully, we've seen what the differences look like. So let's go to talk about quadrilateral hierarchy. What's the hierarchy like? So generally speaking, we have quadrilateral, and then you have a group. You can basically group them into parallelogram, trapezium, kite, and general quadrilateral. Under parallelogram, you can say you have rectangle. So a rectangle is a type of parallelogram. And then under rectangle, you can have square. Square is a type of rectangle, right? Then of course you have rhombus. A square also fits here under rhombus. So a rhombus is a type of parallelogram too. Then you have trapezium. So a trapezium is more like so here you can then have isosceles trapezium where what we saw before, non-parallel sides are equal. So for a trapezium now, you can say that these sides that are not parallel now, maybe this side is not equal to this. Then in that case, you say it is an isosceles trapezium. Non-parallel sides equal, and the base angles are also equal, and the diagonals are equal too in that sense. Okay, that's the case of an isosceles trapezium. Okay. And then we have like I said, we have kites, and then we have general. So kites and rhombus look alike, but kites cannot particularly fit under parallelogram because the general thing about parallelogram, all parallelograms, the actual parallelogram, rectangle, square, the common and rhombus, the common thing to them is that the opposite sides are parallel and equal, right? So every square is a rectangle, as you can see already. And every square is a rectangle, is a rhombus, is a parallelogram, and a quadrilateral. But not every quadrilateral is a square. So now we have extended our idea from the fact that every square is a rectangle, but not every rectangle is a square. But now we see that every square is actually a rectangle, it's a rhombus, it's a parallelogram, it's a quadrilateral. But not every quadrilateral can be said to be a square. Okay? So let's move on to talk about the perimeter of quadrilaterals, which is pretty simple. So the perimeter definition. So the perimeter of any quadrilateral is the total distance around it. So if the lengths are A, B, C, D, then P equals A plus B plus D, A plus B plus C plus D. So if you come back here to each parallelogram you've ever seen, in fact, this is the general parallelogram, right? Is a general, or it has the general quadrilateral, if you like, general quadrilateral. So, um, so if we go ahead and say this is side A, B, C, D, okay? The perimeter is simple to calculate. It is simply A plus B plus C plus D because perimeter is distance around an object. So it's pretty easy and it is still a length. Then next thing, what if you say this is A, B, C, D? The perimeter is still A plus B plus C plus D easily. And for a rhombus, imagine you have A, B, C, D. So the perimeter is still add up all those sides and you have it. So A plus B plus C plus D. That's what the perimeter looks like. For a kite, same story. So you have A, B, C, D. So perimeter is equal to A plus B plus C plus D. So talk about a trapezium too, where you have A, B, C, D. So the perimeter is still the same. Perimeter is equal to A plus B plus C plus D. So for any quadrilateral, the perimeter is simply the sum of the value of each of the sides, basically. So example one now, simple irregular quadrilateral. Imagine you have a simple irregular quadrilateral. So a quadrilateral has side lengths. A is 5 cm, B is 7 cm, C is 4.5 cm, and D is 6.5 cm. Find its perimeter. Perimeter is simply 5 plus 7 plus 4.5 plus 6.5. 5 plus 7 is 4.5 plus 6.5 is 11. Adding them up, you have 23 cm. And that's pretty easy to talk about. Okay. So next we have this example 2. So for example 2 now, um so example 2, finding a missing side. The perimeter of a quadrilateral is 40 meter. The three sides, so you have three sides. Okay, if you are looking for a missing side, and the perimeter of a quadrilateral is 40 meter, the three sides are A, 9 meter, B, 11 meter, C, 8 meter. Find the fourth side, D. So we know that perimeter is A plus B plus C plus D. So that means the perimeter P, which you already know to be 40 meter, is 99 plus 11 plus 8 plus D. So 40 equals 9 plus 11, 20, 20 plus 8, 28 plus D. So D is 40 minus 28, and that's 12 meters. So the fourth side is simply 12 meters. So just a simple addition in that regard. So now let's go ahead and begin to talk about area of parallelograms. So what in talking about perimeter, we don't have to distinguish whether it is kite or rhombus or anything, whatever it is, just add up the four sides and you're good to go. Now we're beginning to talk about areas now, starting from parallelograms. So for a parallelogram, we see the area as a slanted rectangle. Okay, and we know the area of a rectangle is breadth, length times breadth, or length times height, or height times breadth. Whatever you have, length times width, anything. Just multiply the two sides and you're good to go. So parallelograms, here we consider area as slanted rectangle. So the properties of a parallelogram, just to refresh our minds, is that it has opposite sides parallel and equal. Okay, opposite angles are also equal. Diagonals bisect each other. So just like in this first case we saw. So this angle is equal to this angle. This side is equal to this side. They are parallel. This side is equal to this side. Side A is equal to side C. Okay. So A is equal to, so for a parallelogram now. So we are saying that side A is equal to side C, and side A is parallel to side C. Given B is equal to D, and B is parallel to D also. Okay. Then we know that the angle between this angle between AB is equal to the angle between CD. The angle between BC is equal to the angle between AD, like that. Okay. So we have that. Now, how do we talk about the area? So if you now say let the base be B and we have a perpendicular height H, then the area is B times H. Now look at this now. Imagine, so the way this one looks, we need to project a particular height here because normally if it was just a regular rectangle, you just say A times B, and you have your answer. But in this case now, because it is stretched out this way, so you need to get height. You need to get a height H here. So, and once you get that height H, so and you can, of course, since you know B and D are the same, so the area here can easily just be the the base. B is equal to D. So whether I say B or D, you're good. So that's simply B times the height. That's the area in that case, very easily. Okay. So get a height out. So you may have all the information because this height, of course, is going to be perpendicular to this line. So in case you have other information to get that height, in case you don't have the height directly, you can actually use that. So you just have area is base times height, like that. So sometimes the business you have to do is to get the height so that you can work with that. So imagine, why is it like a slanted rectangle? Imagine a rectangle, then cut off a right triangle from one side. Then slide that triangle to the opposite side without stretching it. So you get a parallelogram with the same base, same height, and the same area. So the area formula stays A equals B times H, right? So that's the kind of thing here. So it's more like you have a rectangle. Imagine you have a, a rectangle like we've seen before. So in this case now, you now cut off this part, okay? Let me see, I'm trying to see what exactly that should be. Okay, can you imagine now that you I need to change the marker to demonstrate this. So imagine you now have this part cut off, and then let me make it more uh precise. So imagine you now cut off this part. I want to be as accurate as possible. So you have this. So what that's which you cut off from here now. You now flip it over. Okay. Oh, okay. Okay. Can I just remove this now? Okay. And then that which you have cut off, you now bring it here, right? So that this can even go. So now that you have stretched it like that, so see what you have left. So this is parallel to this is parallel to this, and then this side is equal to this side is equal to this side. So it's but the area is still preserved. Basically, that's the demonstration we have there. So the area is still preserved. So if you drop this, the height remains. So it's still the same height like before. Or you can even do this and you get the height here. And then, but I mean, the height can also be you can also get it inside like this. So this is height, and this whole thing now is the base. So the area remains base times height. That's what that explanation is about, like that. Okay, so we move on and take a first example. So to calculate the direct area, a parallelogram has base B, 12 cm, and height H, 5 cm. So find its area. Solution: area is base times height, 12 times 5, that's 60 centimeters squared. So we're simply saying that the base is 12 cm and the height is 5 cm. That's basically what that is about. And then that means that we have the base is 12 times height 5, all of them in centimeters squared. So this is simply 60 centimeters squared, easily. Okay? So we move on. Example 2 now. For example 2, we want to find height from area. So a parallelogram has area 84 centimeters squared. Base is 14 cm. Find its height. Of course, area is base times height. So that means area 84 equals 14, which is base, times height, h, which you don't know. So h is now divided by 14. 84 over 14, you have 6 centimeters. Pretty easy. And then we have example 3. Now, what if you want to use side and angle for this? So sometimes you know two adjacent sides and the angle between them. So let side length be S and T, and the included angle be theta. So if S is used as the base, then the height relative to S, H is T sine theta, right? So the area is now sine okay, and the included angle, right? So let length be S and T, and the included angle. So S is the base. So what we're trying to say here is that you have this parallelogram. You have this parallelogram. So this is S now. Okay. Of course, this is parallel to this. This is parallel to this. This is the same as this. This is equal to this also. All right. So this is S right here. So imagine that you now have you have this is S, and then you have the height. So this is S right here. I'm trying to see. Hmm. Okay, let's see what this is again. So let side length be S and T, and the included angle be theta. So the side length, you have S here, and this is T, and there's an angle of theta between both of them. So we have S as the base, this is T, and there's an angle theta here, okay? So with this now, we can have this projection that this is now H. So using H and T now, H is opposite now. So we can say that sine theta is equal to opposite, that's H, over hypotenuse, which is T. So H, which you're looking for, is actually T sine theta. So H now gives us the height. And since we have height now, area is base times height. So our base in this case, I mean, I can write that out in full to avoid confusion. Area is base times height. So in this case, our base is S. So we have S and the height is T sine theta. Okay? T sine theta that we got here. So that means the area is ST sine theta easily. Okay? So if we have the included angle like that, we can work with it. So ST sine theta that way. So a very good example is this. A parallelogram has sides. S is 10 cm, T is 7 cm, and the angle between them is 30 degrees. Take S as the base. So H is T sine, H is T sine theta. That's 7 sine 30 degrees is 0.5. That's half. So that's 3.5 cm. So the area is just S, which is 10 cm times the height, which is 3.5 cm. So that's 35 centimeters squared for the area. So sometimes you have the included angle between the two sides, and then you can use that to compute the height, and then you multiply the height by the base, and you get your result easily. Okay, so we move on to rhombuses and kites. So for rhombuses and kites, right, we need to do um diagonal based area. So in this case now, since because of their unique properties, the diagonals intersect at right angle. And one thing we like about triangles is that because they intersect at that right triangle, we have the whole area divided into four right angle triangles. So that's something to work with. So rhombus recap, as you remember, a rhombus is a parallelogram with all sides equal, opposite sides parallel, diagonals perpendicular and bisecting each other, diagonals that bisect the angles. Therefore, a kite has two pairs of adjacent equal sides, one pair of opposite angles equal between unequal sides, then diagonals that are perpendicular, one diagonal that bisect the other, and bisect the angles between each equal sides. Okay, we saw that before. Now, how do we find the area of a rhombus then, or a kite? So the approach is the same. So let the diagonals of a rhombus or kite be D1 and D2. Okay, because the diagonals are perpendicular, they form four right triangles. Easy. I'm going to show you that, not to worry. So each triangle has legs D1 over 2 and D2 over 2. So area of one triangle will now be half base times height. So you have 1 over 8 D1 D2. So there are four such triangles. So A is equal to 4 times 1 over 8 D1 D2. So that's 1 over 2 D1, D2. So we use area is 1 over 2 D1, D2 for both rhombus and kites. Okay, let me explain this thing I've just done now. So imagine you have, of course, we already know a rhombus is like a square. So we have this, right? So and we can have these two diagonals meeting at this. So you can see this area is the same as this area, is the same as this area. And then because it's a rhombus now, so for any of the triangle you take, so imagine if you cut out this triangle, this one and this one. So let's say this one is let's say the whole length of the diagonal is D. Let's say D1 here, and the whole length of the diagonal here is also, of course, they are equal. We already know that. So, but let's say it's D2. But because we're also doing the same for kites, that's why I'm doing this. So let me come for a kite now. So you have this and you have this. Then you now have this now, and then this. So again, these two diagonals meet at 90 degrees. So here now you have this whole length. Let's call it D1. Okay. This whole length is D1. And this whole length, you call it D2. So, I mean, here you could have just said everything is D, but because we are doing the same thing for kite. So you see here, you have um so for any pair you take, you have, this is D1 and D2, right? So for this up here now, you have D1 over 2. This is D1 over 2 also. Okay, I guess I need to change my marker here to actually make things as clear as possible. So here you have, so this length now is D1 over 2 because the diagonals bisect themselves. So this is also D1 over 2. So here you have D2 over 2, and this is D2 over 2. Okay, same here. You have D1 over 2. Yeah. Would that be D1 over 2 though? So like they bisect themselves. Now that's something to think about. Okay. So but basically though, we know this is D1 over 2 and this is D2 over 2 right here. So this is also D2 over 2. So I have a kind of feeling that these ones don't look equal. So that's why I'm really a bit skeptical. But whatever that is, so if you cut one part out now, so if you cut one triangle out, okay, we have this is a right angle, by the way. This is D1 over 2, and this is D2 over 2. Okay, so the area. Okay, yeah, let me go back to that and be sure what's happening there. Okay, yeah. Area of one triangle is half times base times height. Okay, yeah, I think I get that now. So area is usually half times base times height. Okay. So here, if you can pick this one as base, you can pick this one as base. That's common to both of them. So it's common to both of them. That's what we are doing. So we say half. The base is D1 over 2, and the height is D2 over 2. So in that case now, we have our area to be 1 over 8 D1 D2. And because you have 4 of each in each case, so this is 1, 2, 3, 4. For here to this is 1, 2, 3, 4. So however you look at it, so did I say this is area of each triangle now? Area of each triangle. Okay, this is area of each triangle in the rhombus. So finally, we now say area of rhombus. If you're looking at the rhombus or kite, will now simply be, because we have 4 of this triangle in each rhombus or kite, we have 4 times 1 over 8 D1 D2. So that's simply half D1 D2. So in this case, now just get the diagonals and you're good to go. Just get half of the diagonals, multiply them together, and divide by half, and you're good to go. But I still have a bit of concern about that kite thing. One diagonal bisects the other, and one diagonal bisects the other, and bisect the angles between each equal sides. So that's still the one issue I have about kites, but that's it's. I think it's still going. So example one now. A rhombus has diagonals. So for a rhombus, all you just need to know is at the diagonals. You don't even have to worry about the sides. Except if you are not given the sides and you can use that idea to find the diagonals. So once you get the diagonals, you're good to go. So a rhombus has diagonals D1 10 cm, D2 8 cm. Find the area. Of course, we know area is half D1, D2. And that's 1 over 2 times 10 times 8. That's 80 divided by 2, which is 5. 10 over 2, 5 times 8, 40 centimeters squared. On the other hand, for a kite, same. So a kite has diagonals D1 15 cm, D2 10 cm. Uh, okay. Normally, okay, I think it's the same thing. So a rhombus does not necessarily have to. These lengths don't necessarily have to be the same. Yeah, maybe that's why this can pass. Okay, so a kite has diagonals D1 15 cm, D2 10 cm. Find the area. So area is 1 over 2 times 15 times 10. That's 1 over 2 times 150. Oh, that's 75 centimeters squared. And we keep it moving. So finding a diagonal now. So what if you have the area of a rhombus and you need to look for the diagonal? So the area of a rhombus is 54 centimeters squared. One diagonal is D1 99 cm. Find the other diagonal D2. Easy. So area is half D1 D2. So the area is 54. You now have half times D1 is 9, D2 is what you're looking for. So that's 54 equals 9 over 2, that's 4.5 D2. So D2 is 45 over 50, 54 over 4.5. Since 4.5 times 12 is 54, we get that this second diagonal is 12 centimeters. And that takes us to the idea of trapeziums. Okay. By its very definition, we know that a trapezium has one pair of opposite sides that are parallel. So, and then the parallel sides are said to be bases A and B, and we have a perpendicular distance between the bases H. Okay, so like what we saw before, this is this right here. But I mean, I can do another one. Okay, so like now I have this is a very good example of a trapezium. Maybe you have something like this, and then this can come, and then you have this. So this is parallel to this. So these two don't have to be parallel. So we can say the two, A and B, are the bases, and then we need to get a height. Anyhow you want that height to come. So the height can actually come out this way. So you have H. So again, if you have an angle theta here, you can always use that to get the height too. And then you need all the information you get. Okay. You get all the information you need rather. So in this case now, we have a perpendicular distance between bases between the bases, which is this height now. Okay. So with that in place, we can now have area formula idea. So here, two we take two identical trapeziums and flip one to make a parallelogram, right? So the new base is A plus B, and then the height is H. So area of the parallelogram is A plus B times H. So this is twice the area of one trapezium. So a trapezium is actually 1 over 2 A plus B times height. Okay. So in this case now, our area, we see that area is normally area should be base times height, right? But we have half. So you take average of the bases A plus B. Normally in for parallelograms like this, normally you just have the base times height. But because we have to be, so it's like you're taking the average of the bases and then you're multiplying that by height, basically. So that's what that is about. So you have half into the sum of the bases multiplied by the height, and that gives you the area of a trapezium like that. Okay, so half into A plus B times H. So imagine now that you want to find the direct area. A trapezium has base A 8 cm and base B 12 cm. Height H is 5 cm. Find its area. Of course, A is half into A plus B times height. So A is half into 8 plus 12 times 5. That's half times 20 times 5. So that's 10 times 5, which is 50 centimeters squared. So that's like A is 8, B is 12. Okay, in this case now we have to flip it over. So it's like you have okay, so you have, I mean, it doesn't have to be that way only. It can also be something like this. You have this, and then you have this. So you have this, and then you can have something like this. So this is A now, which is 8 cm, B now, which is 12 cm, and then you can then have a height. Can get a height out of this. So the height now is 5 cm. Okay. So now the area is half into A plus B times H. This is half into 8 plus 12 times 5. So that is half into 20 times 5. So that is 10 times, so that's 50 centimeters squared. That's the area in this situation. Okay. So, uh, you can also find height if you have other information that can help you to get it. So, a trapezium has basis A 10 meter, B 6 meter. The area is 64 meters squared. Find its height. So the solution A is half into A plus B times height. So area is 64. That's half into 10 plus 6 times the height you're looking for. So that's 64 equals 1 over 2 into 16H. 10 plus 6 is 16 times height. So 16 over 2 is 8. So 64 is 8H. So H is 64 over 8, which is 8 meters easily. And then what if you want to talk about ramp cross section? A wheelchair ramp has a cross section like a trapezium, right? So the top surface, which is the short base, is 2 meters. The bottom surface, which is long base, is 3 meters. The vertical height is 0.5 meters. Find the cross-sectional area, right? So solution, you have base, the first base is 2, the second base is 3, and the height is 0.5. So just put everything together. You have A into half, A equals half into A plus B times height. So A is half into 2 plus 3 times 0.5. So half times 2 plus 3, 5 times 0.5. That's 2.5 times 0.5, which is 1.25 meters squared. So we can then talk about general quadrilaterals by decomposition. So you can have quadrilaterals joined together, right? So when a quadrilateral is irregular, no parallel or equal sides. Oh, not even not even everything together now. So when a quadrilateral is irregular, no parallel or equal sides, a common strategy is you can draw a diagonal to split it into two triangles and then find the area of each triangle, add the two areas. So a quadrilateral, it can be made up of two triangles. So let me just draw any quadrilateral that does not fit into any of the definitions I've been given all along. So say we have something like this. A quadrilateral has four sides, right? So anything, just any four sides, making no sense. So let's say, I mean, everything is just all over the place, right? So, you know, in this case, now let's just say we have side A, B, C, and D. Okay. So what can we do? We can easily just have split them up into two. This is triangle one, and this is triangle two. So, and we can easily find the area of triangles based on whatever information we know. We talked about solving triangles, right? we talked about if you know, I mean, in this case, now let's assume you know this side A and B, side D and C, and the angle in between them. So we'll get all the information we need to get the area. So just find the area of this triangle, half base times height, and then you're good to go. And then using cosine rule, we can even find that too. Because if you have the included angle, you know that so this side, this angle, so to look for the area now, okay, that's half times base times height. So you can even drop this down. So you get the height, and you need to just find this length, and you can get the base times the half of this base times this height. So anyhow, or you can also divide it this other way. Or again, you can divide it into four triangles too. Like if you drop this line, it can be four triangles, but I think maybe that's even easier. But it all depends because it's an irregular thing, so anything can happen. So just divide it in a convenient way and work it out. So triangle area methods you can use. You can say area is half times base times height, or area is half AB times sine C. That's two sides and included angle. So if you have in this case now, if you are given side A and side B, I now know this angle theta here. The area is simply half A, side B, sine that theta between them. Okay. In the same way, so that'll be area one for this. So for area two now, what if you can imagine that this angle is given as half? Okay. So area two will simply be half C times D sine alpha. Okay. So overall now, the area of that general polygon will just be A1 plus A2, and that's it. Okay. So that's one way to look at that. Half AB sine C, two sides, and included angle. So it's more like the situation you need for cosine rule. You can use it to find area too. So you can also use Heron's formula if you know all three sides. Now, I didn't talk about Heron's formula when I was talking about triangles the other time. Of course, we know this half base times height thing. So that's the first one I explained that you can get the height. You already have the base here and all that. So you can use the Heron's formula. So I'll just quickly refer to the Heron's formula. Um, so for Heron's formula, imagine in this case, you need what you call a semi-perimeter. So the area of a triangle is given as square root of S into S minus A into S minus B into S minus C, where S is equal to A plus B plus C divided by 2, and it is known as the semi-perimeter. So this is known as the semi-perimeter. Okay, this is another way to find the area of a rectangle. So it depends on of a triangle rather. So it depends on the information you have about the triangle. So you can use any of these things that apply. Okay. So that's that. So imagine example one. You have given basis and height, right? So a quadrilateral ABCD is split by diagonal AC in triangle ABC. Okay, I think I need to draw something out here to make it as clear as possible. So you have a quadrilateral ABCD. So let me do that. So a quadrilateral. So I'll just draw it anyhow. So let's assume nothing, it's not like anything we know already. So this is A, B, C, D. Okay, that's our quadrilateral. We are not, we don't know about anything parallel to anything or anything equal to anything. So it is split by diagonal AC. So we have diagonal AC, uh, diagonal AC. So that's diagonal AC right there. What else do we know? We know that in triangle ABCD, the base AC is 8 meters. Okay, we have the base coming here. So this is 8 meters right there, the base AC. And then what else do we know? Height, height to AC is 3 meters. So that's in ABC, right? So height, the base AC is 8 meters. The height to AC is 3 meters. So this is 8 meters right here. So if you drop a height from here, so this height now is 3 meters. Okay. So that's one side now for the ABC part of things. Then in the triangle ACD, the base AC, of course, remains 8 meters. It's still the same AC. But then the height from the height to AC is 4 meters. So now we say the height here is now, so if you drop this height now, it's 4 meters in this case. So, I mean, everything is settled, right? We just already know that we have area. Let me do this. Area of triangle ABC is just half times base times height. That is half. The base is 8, the height is 3. So that is 24 over 2. That's 12 meters squared right there. 12 meters squared. So don't forget for units, right? You usually would have a space in between the number and the unit. So there's 12 meters squared here. Then we now have area of triangle. The other triangle is ACD. Okay, triangle ACD again. That's half times base times height. So that is half. The base is still 8. The height is now 4. So that's 32 over 2. That's 16 meters squared. So you can then talk about the total area. So area of the quadrilateral ABCD now is the area of triangle ABC plus area of triangle ACD. So that is 12 meters squared plus 16 meters squared. That's 12 plus 16 meters squared. That's 28 meters squared, like that. So you split things up into triangles and then you get what you need to get. So that's what we have right here, 28 meters squared, but like that. Okay. Example 2, imagine that we have a field or plot of land, you know. A farmer's plot ABCD is irregular and a surveyor draws diagonal BD. Okay, again, I go over there and try to interpret this as much as I can. So you have, I mean, it's irregular, so just have anything as far as it is called anything, like a plot of land. So and say you can number it anyhow you like. As far as you interpret it, well, you're good to go. So you have that ABCD right there, and then you then have the base. Okay. What's that now? A surveyor draws diagonal BD. So we have diagonal BD. Oh, okay. It's still looking like the AC before, but that's fine. So here we have BD now. BD. Okay. We have BD right there. And then we have base BD is 20 meter. Height to BD is 6 meters. Okay. Base BD is 20 meters. Okay. Then in ABD now, in ABD, height to BD is 6 meters. So this is ABD. So this is 6 meter. That's the height right there. Okay. And then in BCD now, the base is still 20 meters. The height to BD is 9 meters. So this is the height here is now 9 meters. So, I mean, same thing. So I don't even have to worry myself. I can just go through this. So find the total area of the field. So area of triangle ABD is half times 20 times 6, half times base times height. That's 10 times 6. That's 60 meters squared. Half times 20 times 9. That's 10 times 9. That's 90 meters squared. So the area of the field would be 60 plus 90, which is 150 meters squared. And with that, we come to the end of this whole idea of quadrilaterals. And then there are practice questions. So section A, talking about perimeter, a quadrilateral has sides 6, 8, 5, 7. So all the sides are not the same. So find its perimeter. Just add them of 6 plus 4, 6 plus 8, 14, 14 plus 5, 19, 19 plus 7, 26 centimeters. If each side is increased by 1 cm, what is the new perimeter? Of course, it means you have just added 4 to 1 to each side, means adding 4 to everything. So what we had before was, do I remember that? 14 plus 5, 19, 19 plus 7, 26, 26 plus 4. So the new perimeter will be 30 centimeters. So the perimeter of a kite is 48 cm. Three sides are 10, 10, 14. So that'll be 34. So 48 minus 34, that'll just be 14. So the length of the fourth side is simply 14 cm. Okay? So for parallelograms now, a parallelogram has base 15 cm and height 9 cm. So find its area. Of course, we know area of a parallelogram is half times base times height. Okay? So that's half times 15 times 9. and we get our answer. If the base is doubled and the height stays the same, so now the base is 30 and this is the same. So that's 30 times 9 divided by 2. That's 15 times 9 now, and you get what your answer should be. A parallelogram has area 72 centimeters squared and base is 12 cm. Find its height. So area of parallelogram is half times base times area of parallelogram is base times height. Sorry, base times height. Sorry, this is not half base times height. This is 15 times 9 for the first area. When the base is double, that's 30 times 9. Sorry. And a parallelogram here, it's still base times height. So that's 72 divided by 12. That's simply 6 for the height. Another parallelogram has the same area, but the height is 6. Find its base. That's 72 over 6, which is 12 again. So a parallelogram has sides 10 cm and 30 cm, and the angle between them is 60 degrees. Find its area. Of course, the angle between them is this, right? So if 13 is the base, so you have 10 here. So you're going to have 10 sine 60, that's 10 times root 3 over 2 times 13, and you're good to go with that. Then rhombuses and kites. What's happening here? This is not rendering well. For rhombuses and kites, what's the trouble? Do I need to push it down? Yeah, for rhombuses and kites. Yeah, I mean, it's good now. Yeah, sometimes some spacing is required for it to render properly. So for rhombuses and kites, it's nice now. So we have a rhombus has diagonals. D1, that's 16. D2 is 12. Find its area. That's simply 16 times 12 divided by 2. That's like 8 times 12, which is like 96. Each side of the rhombus is 10 cm. Verify that D1 squared, D1 over 2 squared plus D2 over 2 squared is equal to side squared. Fine. So a kite has area 96 centimeters squared and diagonals are D1 and X. So, I mean, find X. So 96 is equal to half times 12 times X. That's like 6X. So X itself will be 16, I think. So D2 is 6 centimeters. Then for trapeziums, you have this. So a trapezium has base 7 cm and 13 cm and height 6 cm. Find its area. Trapezium. So the bases are, so you just have half times 7 plus 3 times 6. That's half times 20. That's 10 times 6, which is 60 centimeters squared. The area of a trapezium is 90 meters. The bases are 8 and 12. Find its height. Of course, that's like half into 8 plus 12 is 20. That's 10 now times the height. So height is simply 9 meters squared. That's 90 over 10. That's 9. Then a road cross section is a trapezium with both width 4 meter, bottom width 6 meter, and depth is 0.8. Find the cross sectional area. That's half into 4 plus 6 times 0.8. That's 5 times 0.8. That's 4, I think. That's about 4. Then section E, general quadrilaterals now. So a quadrilateral is divided by diagonal into two triangles with areas 35 and 42. Find the total area. Just add them up. That's 77 meter cube squared. Then if each area is double, what is the new total area? That's 70 plus 84 now. That's 150. 70 plus 84. That's 154 meters squared. Easy. So if quadrilateral ABCD diagonal AC is 18 meter, the height of AC in the two triangles are 4 and 7. So just say half times base times height. That's half times 18 times 4 plus half times 18 times 7. And that's it. So with this, we come to the end of this interesting video about quadrilaterals, talking about parallelograms, talking about rhombus, kites, and trapeziums. And, we've seen all the beautiful things we can do with this. Let me know how helpful this is. And if there's something else you'd like me to try out, feel free to let me know. If you have subscribed already, I thank you very much for doing that. If you have not subscribed, what are you waiting for? Go ahead and subscribe right away and hit the notification bell so you can always get alerted each time a new video is released. Having done that, you should also know you can become a member of this channel by clicking on join, and that gives you some special privileges like hanging out with me at the highest level. We can hang out together if you're in the same geographical zone at any point in time. And if you're not, we can hang out online to talk about anything that interests you on my channel, be it mathematics, data science, data analysis, machine learning, Python programming, whatever, scholarships, personal development, writing books, anything that interests you on my channel. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing maths right. Bye.